This video is going to cover adding 3 or more vectors algebraically. So in order to do this method, we need to break each vector into its components, which is what we covered 2 videos ago when looking at a vector and breaking it into its vertical and horizontal components. So when we do this, we basically take each of our displacements, okay, so this would be for vector 1, vector 2, vector 3, but we just take the x component, okay, and we're going to add up all of those in order to determine the total displacement in the x direction, okay, and then we do the same for the y axis, so we add up all of the y components of each of the 3 vectors to get the total y displacement. So then what we do is we take both the total x and the total y to make one large triangle to find displacement and direction. So here, if I have my vector 1 and vector 2, okay, if I break up vector 1 and its x and y components, its x component would be this, its y component would be this. And then if I were to break up this vector and its components, its x component would be this one, and then y would be this one. So I can stack these together to create one large triangle that then I can use perpendicular rules in order to solve. Okay. Please note too that you can use this method of breaking up the vector components for the previous video as well. So whenever we have non-perpendicular, as you can see here, I only have 2, and the method still works for that. Okay, so I'm going to talk you through the example. So we had a horse that traveled, and we were given 5 different vectors. Okay, so again, this is a key thing, is just keeping organized. So I went ahead and labeled each of the vectors with a name. So displacement of 1, 2, 3, 4, and 5. Okay, so I'm going to go ahead and make a chart, which I did here. Okay, so I have my horizontal aspects and my vertical aspects. And then over here will be where I show all of my work. I did just go ahead and set up my compass so that I know that the eastern and northern direction is the positive, whereas western and southern is negative. So to start, I took my first vector, which was 55 meters west. Okay, since it's just west, it's not going to have a vertical aspect, so I put 0. Okay, but the displacement for the horizontal would be 55, but it would be negative because it's west. Okay, for my second vector, I have 25 meters south. So again, because I'm given just a singular direction, I don't have a horizontal in this case, so I have 0 meters. Okay, but my vertical is going to be negative 25 because it is in the southern direction, which we have decided is negative. Okay, for the next 3, we're given a vector that is not just in one direction, so we have to use the component method to break it up into its horizontal and vertical aspects. So I have 67 meters south, 17 degrees west. So I went ahead and I drew my compass, and from the south border, I went to the west 17 degrees. So I drew in my vector here. Okay, put in my 17 degrees, wrote down what my side is, okay, my hypotenuse. So in order to solve for x and y, I'm just going to use sine and cosine. So for x, because it's opposite the angle, I did sine of the angle, 17 degrees, is equal to x divided by 67. So I just multiplied both sides by 67 in order to solve for x. Okay, and then for y, I did the cosine. So I did sine of angle 17 is equal to adjacent, which is y, over my hypotenuse of 67. Again, I multiply both sides by 67 to get y by itself, and I get 64.07. So when I go to write down the horizontal and vertical aspects, I need to look back at my diagram in order to determine if it's in the positive or negative direction. So my x is going to the west, so that would be negative. So I report my horizontal aspect as negative 19.59 meters. And then for my vertical aspect, again, it's in the southern direction, which is negative, so I report it as negative 64.07. Okay, for these other two, I also just broke it up. So again, looking at my original vector, I drew my compass from the northern border. I'm going to go east 33 degrees. Okay, so I drew in my vector. I drew my corresponding x and y components of this triangle. Okay, and then use sine and cosine in order to solve for those. But once I solve, again, I go back and look at the direction. So in this case, y was positive, x was positive. Okay, so I'm not going to talk through solving for both of those. But once I get all of the horizontal and vertical aspects of all 5 of my vectors, I'm going to go through and add. So I'll do negative 55 plus 0 plus negative 19.59 plus 7.08 plus negative 11.74. Okay, and then I do the same for vertical. I add up all of the vertical aspects. So my total x displacement is going to be negative 79.15, whereas my total displacement in the y component is going to be negative 57.18. So I'm going to use these two in order to make a large triangle that is my resultant in order to find my my total displacement. So for my x, it's negative 79.15, so I went to the west. Okay, and then my y is negative, so I went south 57.18 meters. Okay, so the resultant displacement, or my total displacement, is going to be here. And then for my direction, I'm going to have to find this angle theta. Okay, so again, then this just goes right back into how we solved for our perpendicular triangles. So to find my magnitude of displacement, I'm going to use Pythagorean theorem. So I did my c squared equals a squared plus b squared to find the displacement to be this. Okay, and then to find my direction and this angle theta, I did tangent of theta is equal to opposite over adjacent. Okay, and then I took the inverse tangent to get it 35.8 degrees. So when I look back at the problem, I have 2 sig figs, 2 sig figs, 2 sig figs, 2 and 2. So I'm going to report my answer into 2 sig figs, which I did. The displacement magnitude is going to be rounded up to 98, and then the direction, we're going from the west border south 36 degrees, so that is how I reported it.